Hello, and welcome to Summarize Science. Have you ever wondered why even the most powerful AI language models can sometimes feel a bit slow? A big reason is that they generate text sequentially, thinking about just one word or part of a word at a time. But what if an AI could think in entire phrases or chunks of ideas all at once? That's the core idea behind a groundbreaking new paper on continuous autoregressive language models, or COM for short. Instead of the old token-by-token method, COM uses a clever process to compress a chunk of, say, 4 tokens into a single, dense vector. This means the AI model now only has to take one step to generate what used to take 4, fundamentally speeding up the process. You can think of it like upgrading your internet connection's bandwidth. Each piece of data sent is now much richer and contains more information. The researchers designed this compression to be incredibly precise, able to reconstruct the original 4 tokens from that one vector with over 99.9% accuracy. But this radical new approach broke all the old tools used to train and evaluate language models. Predicting a point in continuous space is vastly different from picking a word from a finite dictionary. So, they had to develop a whole new toolkit from the ground up. This included a new way to train the model without traditional probabilities, which they call a likelihood-free framework. They also created a new metric to measure performance, called Breyer-LM, since the standard ruler for LLMs, perplexity, no longer worked. And as you can see from this chart, their new Breyer-LM metric is incredibly consistent with the old standard, proving it's a reliable way to measure how good the model is. So, does it actually work? The results are seriously impressive. This table shows the head-to-head comparison with standard transformer models. A COM model achieved performance comparable to a strong baseline, but it required 44% fewer computations for training and was 34% more efficient during inference. That means it's cheaper to build and faster to run, without sacrificing quality. The framework also introduces a new lever to pull for optimizing AI. Instead of just scaling up model size, developers can now scale the semantic bandwidth, or how many tokens are grouped into one vector. This chart shows there's a sweet spot. Grouping 4 tokens together gave the best trade-off between performance and computational cost for this model size. So, let's recap the important points. The COM framework fundamentally changes how language models generate text, shifting from a slow, one-word-at-a-time process to generating entire chunks in a single step. This makes the models significantly more efficient, reducing the computational cost of both training and running them. It establishes a new and powerful axis for scaling AI, focusing on the information density of each generative step, not just the raw size of the model. This research could pave the way for ultra-efficient language models that are faster, more accessible, and more sustainable to operate in the future. That's all for today. Thanks for watching Summarize Science.